Good afternoon, dear students. Today we will start a new topic called quadrilaterals. And before I proceed further, I just want to take a confirmation that all of you are able to view the screen properly and able to hear my voice very clearly, right?
Yes, sir.
All right, thank you. So fine. And, you know, if you recall that in our earlier classes we discussed about triangle and what how we form a triangle is that if we join three non-collinear points, okay, in pairs, we the figure so obtained is a triangle. Okay. Now let us increase that number of points by 1 and let us mark 4 points and see what we obtained on joining them in pairs. Correct? So what does it mean? It means is that suppose if I and there are 4 points. Let me place this statement in front of you. This particular diagram. So if you see, there are 4 figures here. 4 points, and all these 4 points are actually joined in pairs. If you notice that if all the points are collinear, which is the case 1, okay, what we obtained a line segment. Correct, dear student? See, the black dots, these are the 4 points. What you see, the black dots, these are the 4 points. Okay, and what we are doing is that all these 4 points, when they are joined together, what we get a line segment. So this is the first one. What you see, it is a line segment. Correct. So if I say this one is a line segment. Now if you look into the the diagram 2, okay, if 3 out of these 4 points are collinear, then what we get a triangle when we join them, these points in pair. Right? So what we get here is that is a triangle. What you see here is that the 3 points out of these 4 points, 3 are collinear points. Correct? And we get what is a triangle. Now, when all the if no 3 points are or 4 are collinear, okay, if no 3 points out of the 4 are collinear, what you obtained? We obtained a closed figure, as you see in diagram 3 and diagram 4. I repeat, if no 3 points out of these 4 points are collinear, that means 3 points are not collinear out of these 4 points. What you obtain? We obtained a closed figure, and as you see in the diagram 3 and 4, okay, and this such a figure by joining 4 points in an order is called a quadrilateral. So what we see, dear students, here, okay, that you see the diagram 3, okay, and diagram 4. So what we are interested to discuss on diagram 3, okay, not on the diagram 4. Okay, diagram 4, if you see, there are also the 4 points where we are joining, but we are interested to discuss on the diagram 3. Okay, diagram 3. So what I repeat my statement, dear students, is that a figure formed by joining 4 points in an order, okay, is called a quadrilateral. So whatever we are going to discuss now, which is surrounded by this diagram, which is there in the diagram 3, okay, but not in 4. I'll show you and I'll explain you in details why we are only interested in 3 and not in 4. So a quadrilateral has 4 sides, 4 angles, and 4 vertices. So what we see is that if you see a quadrilateral has 4 sides, 4 angles, and 4 vertices. Let me show you, then it will be very clear to you. So dear students, look at here that a quadrilateral has 4 sides, 4 angles, and 4 vertices. So as you see in this diagram that this quadrilateral is ABCD, and there is a way to name it, dear students. Always recall that the way you can name that quadrilateral A, then after that come to B, then C, then D. Okay, in that is a proper way of naming. So you can make it in this way, in the anti-clockwise direction. Okay. Now, if you name it in the clockwise direction or some other way, I'm not telling it is wrong. But what is common practice? What is proper way of representing is that, in an anti-clockwise way of naming. Okay. For example, if you start naming from, suppose there is a quadrilateral here, suppose like this. Let me draw it properly. Suppose I have a quadrilateral something like this. If I start naming from here, no problem. You name here A, then go to B, then C, then D. Okay. So that is a common practice. That is a good practice also, I will say. I will recommend that this is the way to you name the quadrilateral. So if you see in this quadrilateral ABCD, AB, BC, CD, and DA are the 4 sides. A, B, C, D are the 4 vertices, and angle A, angle B, angle C, angle D are the 4 angles. So as I said, the quadrilateral has 4 sides. What are those 4 sides? A, B, B, C, C, D, and D, A. 4 angles. What are those 4 angles? That is angle A, angle B, angle C, angle D. And 4 vertices. What are the 4 vertices? A, B, C, D are the 4 vertices. Correct, dear students? Now, what we are going to join? We are going to join A and C. As you see, that is the dotted line between A and C, and dotted line between B and D. So what we get? AC and BD, these are known as the diagonals. There are 2 diagonals, and these diagonals are AB, AC, and BD. So what we are going to discuss moving forward, that we will study more about different types of quadrilaterals, their properties, and especially one type of quadrilateral we will discuss in details, that is called a parallelogram. So far it is absolutely clear, dear students. Any doubt you have? Absolutely clear? Any doubt? Okay, great, fine. So you may think, that why there are different type of quadrilaterals, and why we should study them. So before moving forward, though, I just would like to tell you that one very important property, and that is called the angle sum property of a quadrilateral. Okay, so that I'm going to discuss with you now. That if you recall our triangle discussion days, that when we discussed about triangles, there also we discussed about the angle sum property of a triangle. Now what we are going to discuss is that angle sum property of a quadrilateral. So let me first show you a quadrilateral, and from that we are going to derive this one. So look into it. This is a quadrilateral. Okay. And what we are going to find, ABCD is a quadrilateral. Now, what we are going to find is that we are going to find that what is that angle sum property of this quadrilateral. That means if we add up these 4 angles, A, B, C, and D, what we are going to get. Okay. The statement is that the sum of the angles of a quadrilateral is 360 degree. many of you are aware of it. Okay, and that is the most easiest way of proving it is something like this, that we join that AC as the diagonal. Then what we get, this angle plus this angle plus this angle is 180 degree. Correct, my dear students? Now if I make a different color, suppose a green color, then this angle plus this angle plus this angle is 180, because that we know from that angle sum property of a triangle. Now you add up all this, then what we get? Angle sum properties of a quadrilateral, that is 180 plus 180, that is 360. Correct or not? So suppose what I was telling is that if we name, suppose in the triangle, ABC, so what you know, that angle, CAB, angle CAB plus angle B plus angle BCA is equal to 180 degree, and that I give as equation 1. And in the triangle ACD, what we get is that angle DAC plus angle ACD plus angle CDA, means I can tell that is angle D, that is equal to 180 degree. Now what we are going to do, dear students, is that we are going to add these two equations. So that means if we add equation 1 and equation 2, what we are going to get? That angle CAB plus angle DAC, that becomes is actually angle A. So let me write it down. So what we are going to get, angle CAB plus angle DAC plus angle B plus angle BCA plus angle ACD. So I club together, and plus angle D is equal to 180 degree plus 180 degree. Correct? So from here what we can say, dear students, if you see angle CAB plus angle DAC is nothing but angle A. Angle B I keep as it is, plus angle BCA plus angle ACD is nothing but angle C. And angle D I keep as it is, 180 plus 180 is equal to 360 degree. So this is the angle sum property of a quadrilateral. Okay, dear students, I hope it is well understood that what is the angle sum property of a quadrilateral.
Yes, sir.
Yes,
Okay,
sir.
great. Now, and this is the best way of proving it. The sum of the angles of a quadrilateral is 360 degree. We can say with much confidence that yes, we are able to prove it, and we are able to prove it with our information what we are aware of, that is the angle sum properties of a triangle. Now, dear students, what I'm going to discuss now is the different types of quadrilaterals, and that I want to spend some time on this, that what are the different types of quadrilaterals, and we are going to discuss more on that. So to find different types of quadrilateral, so what I will prefer, dear students, is that I want to show you different types of quadrilateral, the the diagram of different types of quadrilateral you can think of. So, for example, I think about this diagram. As you see, these are the different quadrilaterals, correct? You know, if you can think of any other quadrilateral, okay, apart from all these figures, you can let me know. But these are the quite common thing. And dear students, all these quadrilaterals, we'll see moving forward. They have different properties, they have different names, and there are theorems, related to all these type of quadrilaterals. One thing is common. Whatever you see in these, all these, these six, figures, what you see, all of them are quadrilateral. That is one thing is common. If you look about it is just like a subset. They are different type of figures, but all under a superset that is called the quadrilaterals. Now let us focus on one by one. The first focus I want to give it to you. If you look into it, that is the first one. If you look into the first one, dear students, so what you are going to get, you see, is that could you please tell me what is the first figure, what it is, dear student?
Sir, it's a
Trapezium.
trapezium.
Correct.
Trapezium.
So, what is a trapezium then? A trapezium is a quadrilateral with a pair of parallel sides. Correct, no? So, what we understood is that trapezium is a quadrilateral with a pair of parallel sides. So, if you see, what are the two sides are parallel here? So, here the two sides are parallel is, AB and DC. Correct or not? Now, and the other two sides, they no need to be parallel. And one important information here, dear students, if the non-parallel sides of the trapezium are equal, then it is called an isosceles trapezium. For example, if you get a if you get a trapezium in which the non-parallel sides, for in context to our discussion in that ABCD, that quadrilateral, which is also a trapezium, in addition to that AB parallel to DC, if we see that AD and BC are equal, then we can call this trapezium is an isosceles trapezium. So what we see, dear students, we see that the trapezium is a quadrilateral with pair of parallel sides. Correct, dear students? So I can write this thing. So this is known as a trapezium. So we can call this as a trapezium. So I'm writing on top of it so that you can later you can make you understand that why I wrote this thing. Now let's look into the diagram 2, 3, and 4 and 5. 2 and 3 and 4 and 5. If you look into all these things, if you notice that the pair of opposite sides of this quadrilateral, okay, are parallel. Okay. Now this type of quadrilaterals are known as parallelogram. Correct, dear students? So what is the definition of a parallelogram? Parallelogram is a quadrilateral with each pair of opposite sides parallel. A parallelogram is a trapezium, but a trapezium is not necessarily a parallelogram. That we'll discuss later. Okay, but one thing is quite common. What I said is that is the fundamental definition of parallelogram. I repeat, dear students, and as you hear from my statement, you can also take a note of it. Parallelogram is a quadrilateral with each pair of opposite sides parallel. For example, if you look into this one, that diagram 2, you see this one, that PQ is parallel to SR, and again QR is parallel to PS. Correct? Similarly, you see that MN is parallel to SR and NR is parallel to MS. You look into this diagram 4, DE is parallel to ZF and EF is parallel to DG. Look into 5, that AB is parallel to DC and PC is parallel to AD. So all these diagram, dear students, the diagram 2, diagram 3, diagram 4, and diagram 5, all are actually coming under the definition of a parallelogram. Why it is so? I repeat once more, because we know the definition of a parallelogram is such that it is a quadrilateral with each pair of opposite sides parallel. Correct? Now, keeping this definition in mind, what we say is that diagram 2, diagram 3, diagram 4, diagram 5, all are parallelogram. Now, we are going to discuss the different types of, there is a parallelogram of different types, and then we get their different names and their different properties. Okay. But whereas I didn't discuss about the diagram 6, diagram 6 doesn't qualify to be a parallelogram. Okay. Why it is no? Because if you see the opposite sides, they are not parallel. For example, in the diagram 6, if you take that AB and DC extend together, you will see they will meet each other at some point. And same thing for the other two parallel and other two opposite sides. They are not parallel, AD and BC. If you extend them, they will meet somewhere. So that is why the diagram 6 doesn't qualify to be a parallelogram. Correct? Now let us look into all this diagram from diagram 2 to 5 with with more interest. So let's now look into the diagram. Let's look into the diagram. Diagram 2 is a parallelogram. Diagram 3, if you look into it, that MNRS, as you see that MNRS, it is a parallelogram as it satisfies the definition of a parallelogram, but we can tell this is a rectangle as well. Why Because one of its angle is right angle. In a parallelogram, note that one of its angle, namely, is a right angle. And then what kind of this special parallelogram is? This special parallelogram is known as a rectangle. Correct, my dear students? If you remember, rectangle, the definition of rectangle is what? The definition of rectangle is that it is a parallelogram with a right angle. So that is why it qualifies to be a, if you look into the diagram 3, so we can say this is a rectangle. Any doubt at any point of time, never hesitate to let me know, dear students. I repeat, the definition of a rectangle is that it is a parallelogram with a right angle. Okay. For example, here one angle M, that is right angle, hence it is a rectangle. Now let's focus on that diagram 4, dear students. If you look into the diagram 4, what we see is that the diagram, it is a parallelogram, DEFG, that is a parallelogram. But one interesting thing is that all these four sides are equal. As all these four sides are equal of a parallelogram, okay, then we can call this is a rhombus. Okay, the definition what I say is slightly I can change. An exact way I can say is that a parallelogram with sides of equal length is called a rhombus. Sometimes, dear students, I have noticed from my experience, the moment I give that definition, students actually get confused with square. But wait for just couple of minutes or 5 minutes, you will understand the fundamental difference between a rhombus and a square. But before,
sir, I have a doubt.
yes, please. Thank you for asking question. Please do let me know.
Sir, it was actually in the previous one, in the rectangle, only one angle has to be 90 degrees, or all of them have to be 90 degrees?
Okay, good question. With one, if the point is that if one angle is 90 degree, the other angle has to be 90 degree. Otherwise, it's not possible. Why Good question. That suppose angle M is 90 degree, according to our understanding. Then if you see, as we know that MN is parallel to SR and MS is a transverse line, so then definitely this angle has to be 90 degree. Na?
Oh, yes, sir.
Correct or not? Clear or not clear? So in that
So,
way, yeah, please.
So sir, if it's one right angle, it means that all of them will be
All has to be
right
right
angles.
angle. Yes, exactly. Otherwise, why the other three angles has to be 90 degree? Because in a parallelogram, we know the opposite sides are parallel. As I said
Yes, sir.
just now, that why with that only one information that angle M is 90 degree, we are able to prove that angle S is also 90 degree. Correct?
Yes.
How? Because we know that MN is parallel to SR and MS is the transverse line. Correct? In the similar manner, you can prove
Yes,
that
sir.
angle N is 90 degree because SM and RN both are parallel and MN is a transverse line. Correct? In that way, you can
Yes,
prove
sir.
that this is also 90 degree. And the moment you are able to prove three are 90 degree, the fourth has to be 90 degree because the angle sum properties of a quadrilateral is 360 degrees. Is correct?
Yes, sir.
There are multiple ways you can prove it. Okay, I just say one, but I appreciate your question that whether all has to be 90 degree, all will eventually be 90 degree. The moment I say that one right angle, it is a parallelogram with one right angle, that actually eventually says that all the other three are also right angle because of that inherent definition of a parallelogram that the opposite sides are parallel. Got it?
Yes,
Clear?
sir.
Okay, great.
Yes, sir.
Now let us come to the the diagram 4. If you look into the diagram 4, that is DEFG, all these four sides are equal. So, and then we call this special type of parallelogram, we call it as a rhombus. So dear students, what is a rhombus? Rhombus is a parallelogram with sides of equal length. What we see here is that DE is equal to GF is equal to EF is equal to DG. So that we call is a rhombus. Correct? Now, if you look into the next diagram, that is diagram 5, that is also looks like a rhombus because all the sides are equal. And you can say, sir, just a minute back you defined that rhombus is a parallelogram with all the sides equal. Okay. Then we can say that the diagram from 5 is also a rhombus. You know, the point is that there is another definition of a parallelogram when all the four sides are equal and one angle is 90 degree, then it qualifies to be a square. Correct, dear students? So what I wanted to say is that what is a square? Square is a rectangle with each side of equal length. Every square is a rectangle and also a rhombus, but a rectangle or rhombus is not necessarily a square. My last statement is of very meaningful. Let me repeat once more. So what is the definition of a square, dear students? Square, you can say it is a rectangle with sides of equal length. The moment I say this thing, that means what? The moment I say the square is a rectangle, that means one angle is 90 degree. Correct? And then one more statement I'm telling on top of that rectangle, that a square is a rectangle with sides of equal length. That means AB is equal to BC is equal to CD is equal to DA. So it qualifies to be a square. Now the next statement is also important. Every square is a rectangle and also a rhombus. We can say that square is also a rhombus, but rhombus is not necessarily a square. Why? Because for rhombus, it is not a condition that the angle has to be a 90 degree. The only condition to be a rhombus is that all the four sides has to be equal. Now on top of that equal, if we find the angles are 90 degree, our bare minimum requirement is that one angle is 90 degree. For example, in this case, the angle A is 90 degree, then the rhombus qualifies to be a square. So the simple way of defining this thing is that, a square is a rectangle with sides of equal length And then my next statement is that every square is a rectangle and also a rhombus, but a rectangle or a rhombus not necessarily be a square. Correct? Why a rectangle cannot be a square? Because a rectangle, to qualify to be a square, all the four sides has to be equal. So unless all the four sides are equal of a rectangle, we cannot qualify to be a square. For example, if you see in that MNRS, that is a rectangle, but that is not a square. Why? Because the length of the side MN is not equal to the length of the side NR. Hence, it is not a square, though it is a rectangle. But if you see that, square, that ABCD, this square I'm talking about, ABCD, that we can tell it is a rectangle also. Why? Because it satisfies the definition of a rectangle. What is that? Because it is a parallelogram and with one angle is 90 degree, which is angle A is 90 degree. Similarly, we can say that ABCD, that square, is a rhombus. Why? Because it satisfies the definition of a rhombus. What is the definition of a rhombus? The definition of a rhombus is that it is a parallelogram with all the four sides equal. That is what we define as a rhombus. That a parallelogram with all the sides equal. But rhombus, if you look into it, that DEFG, that doesn't qualify to be a square. Why? Because to qualify to be a square, that one angle has to be 90 degree. And here you see that angle D, for example, that is not 90 degree. So it is not a square, though it is a rhombus. Dear students, my humble suggestion to you is that do not, remember whatever the, exact definition is there in your book. Remember the fundamental definitions, what is coming out of the diagram. Okay, as I said in the beginning of the discussion, if you can think of any other diagram of a quadrilateral, you can let me know. Or if you think that no, I'm not able to remember now, I'll let you know later. We are most welcome. But the point is that always define when you visualize a diagram. For example, if someone asks you, hey, what is the definition of a rectangle? Then you should visualize what is a rectangle. And then the definition should come from, within you, from inside you, the definition will come from your understanding, not whatever exactly written in the book. Okay? If you can say, yeah, it is a rectangle, is a parallelogram with, one angle is 90 degree, perfect, done. Or if you say it is all the four angles are 90 degree, then also it is fine, right? So always give definition based on your understanding, and your understanding is only getting clear if you have a very, very clear idea. The way I explain, you should also consume in the same manner and also ask question. It is clear, dear students. Now I hope it is absolutely clear what is trapezium, what is parallelogram, what is rectangle, what is rhombus, what is square. Now I come back to the diagram 2, dear students. If you look into the diagram 2, what you see here, you see this is a parallelogram. Okay, why? It is, there is no special type of name of this thing. Actually, it is a special type of quadrilateral, you can say. Okay, so this is a parallelogram. Now we can say that diagram 3, that is also a parallelogram, diagram 4, that is also a parallelogram, diagram 5, that is also a parallelogram. But more than this parallelogram, we have a special name based on their different properties. So for diagram 3, we call it as a parallelogram, but it is a rectangle, more, a special type of parallelogram, we can say. Similarly, for diagram 4, that is a parallelogram. Yes, rhombus is a parallelogram, no doubt about it. But it is a special type of parallelogram. And what is the special, that I already defined? Hence, it qualifies to be called as a rhombus. Similarly, if you look into the diagram 5, that is also a parallelogram. A square is a parallelogram, but it qualifies to be a different, different properties, and hence we, on top of the properties of a parallelogram, hence we call it as a square. Correct, dear students? Now, I'm going to emphasize on the diagram 6. If you look into the diagram 6, dear students, what you see is that AD is equal to CD and AB is equal to BCB. That is what? Two pairs of adjacent sides are equal. Okay? So, it is not a parallelogram. So, It is a quadrilateral, but it is not a parallelogram. Why it is not a parallelogram? Because, as I said few minutes back, that if you take the two opposite sides, suppose AB and DC, suppose you take this one AB and DC, if you extend them, na, you will find they will meet somewhere. You will meet there. So it is not a parallelogram because it doesn't qualify the definition of a parallelogram. It doesn't satisfy the definition of a parallelogram, that opposite sides are parallel. If we extend the opposite sides and they intersect at a point, how come they become parallel? So hence, it is a quadrilateral, but it doesn't qualify to be a parallelogram. Correct, dear students? But here we see, dear students, that AD is equal to CD and AB is equal to CB. That is, two pairs of adjacent sides are equal. It is not a parallelogram, it is called a kite. And if you, dear students, if you notice that if you have a experience with kite flying or something, you see the kite generally looks like this, right? So I can say that the definition of kite like this: kite is a quadrilateral with exactly two pairs of equal consecutive sides. You see the different way I'm defining. Okay, a kite is not a parallelogram. Okay, all right, dear students. So far what we have learned about parallelogram, rhombus, rectangle, then square, and then kite, all coming under the territory of a quadrilateral. And we all know about their differences and their similarities. Okay, now I want to give you a exact tabular format so that you can understand that exactly how we can make a difference among all these things. Correct, dear students? So here I'm going to write it down. Okay, and if you find any if you have any statement, any comments, never do not hesitate to let me know about it. Okay, so what I'm going to discuss now is that important properties of all this parallelogram, rhombus, rectangle, square, and kite. So I'm going to write it down here, dear students. Important properties. The first one is the parallelogram. So what is that? The first important properties of a parallelogram? Opposite sides are equal. Correct, dear students? I hope you agree to me.
Yes,
Then
sir.
Yes, sir.
eventually we can say opposite angles are equal. Correct. And number 3 is that diagonals bisect each other. And dear students, you may have questioned that, sir, how come diagonals bisect each other? Okay, so for that I will give that. Okay, I will leave it to you. You prove it. If you are not able to prove it, then please do let me know. Okay, and the fourth one is that about parallelogram, what we can write is that adjacent angles are supplementary. Correct. So these are the 4 important properties of a parallelogram. Anyone has any doubt, let me know. But proof of all these things, I leave it to you. I want you to prove it. Correct, dear students? Clear? Now
Yes.
I'm coming to the next one. Let me do it in a different color, and that is I want to define for the important properties of rhombus. So the important properties of the first property, what we can say about rhombus is that all the properties of a parallelogram, okay, all the properties of a parallelogram, on top of it, the diagonals are perpendicular to each other, are correct, dear students? Got it? Absolutely clear?
Yes, sir.
Now, the next one
Yes,
I'm
sir.
having is that next one, next one, what I'm going to discuss is about the, as we are done with that, let me move it little bit up. Now, next, what I'm going to discuss is for the rectangle. So, let me use a different color so that you can make a difference later. So for rectangle, what you can say is that all the properties of parallelogram, because rectangle is a parallelogram, correct? All the properties of a then on top of it, what we can say is that next one, what you can say that each of the angle is a right angle. Each of the angles is a right angle. Dear Srivali, if you recall that I said during the definition, one angle is right angle, then eventually we found that all the other angles are right angle. Correct, no? That's why we said that each of the angles is right angle. Okay?
Yes, sir.
And the third property is that diagonals are equal. Correct? That is the definition of a rectangle. Okay? So you can write like this also. If someone asks you what is parallelogram, you can tell all these 4 points. Opposite sides are equal, opposite angles are equal, diagonals bisect each other, and adjacent angles are supplementary. Then what is rhombus? You can say all the properties of a parallelogram. Then on top of it, we can say the diagonals are perpendicular to each other. Similarly for rectangle. Then after rectangle, what I'm coming, dear students, is that the next one is called the square. Okay. So let me use a different color. Let me use the blue color. So here what I'm defining is that is a square. Square. So what we can say is that only one way we can define is that all the properties of a parallelogram plus rhombus plus rectangle. If you add all these properties of parallelogram, rhombus and rectangle, you get a square. Correct, dear students? So now the next one what we are going to discuss is next one what we can say is that I want to define sorry, let it be like this thing, and sorry, now is that kite. So let me write down the kite in a different color, suppose in this color. So kite, so dear students, so what is the first property is that the diagonals are perpendicular to each other. Diagonals are each other. And the second property, dear students, is that one of the diagonals bisect each other. One of the diagonals okay, dear students. So These are the, you can, I will suggest you that you also take a note of it and have a very clear understanding about all these different types of, all these different types of, you know, parallelogram. Okay. I hope you are able to view it, all these points. Correct, dear students? So, let me repeat once more. A parallelogram, what are the properties of parallelogram? That opposite sides are equal, opposite angles are equal, diagonals bisect each other, adjacent angles are supplementary. These four are the properties of a parallelogram. What are the properties of rhombus? All the properties of parallelogram is valid for the rhombus. On top of it, what we can say in a rhombus is that diagonals are perpendicular to each other. Now, next is the rectangle. What are the properties of rectangle? All the properties of parallelogram plus each of the angles is a right angle and diagonals are equal. Correct, dear students? Absolutely clear. Now, next one is square. Square is nothing but if you add the properties of parallelogram, rhombus, and rectangle, you will get the properties of squares. And finally, it is coming to kite. What is kite? Kite is the diagonals are perpendicular to each other. That is the first property. And second property is that one of the diagonals bisect each other. So dear students, I hope you get a very clear idea about all these different types of parallelogram except kite. Kite is not a parallelogram. Anyone has any doubt here, dear students?
No, sir.
Okay.
No, sir. So,
Okay.
sir, just a clarification.
Please.
In the kite one, only one angles bisects the other. That like the other one doesn't bisect the other.
Yeah, may not. Not the other one is not. If you look into it. So if you look into that, I first of all I appreciate your question. And if you see the diagonals, so these are the two diagonals of a kite. No? So let me draw the diagonals in a different color. Suppose in the purple color, let me draw. So this is one diagonal, no? Correct? And this is one another diagonal, correct?
Oh, okay. So BD bisects AC, but AC does not bisect BD.
Correct, correct,
Yes,
correct.
sir.
Exactly. So, dear students, and this is such a fantastic question. I appreciate your question. So, the thing is that, the moment you have your understanding clear in your own terms, you have to have your idea clear, understanding clear in your own terms. Perfect. Thank you. Now, shall we proceed further? Okay. Now, I just want to tell you 5 points, and and if you disagree, you can let me know. The all the statement what I'm going to say is a correct statement, but correct statement doesn't mean that you need to always say yes. That doesn't mean that statement is wrong. That means is that maybe your idea is not clear. So you should say, sir, explain me all these properties. The first property is that a square is a rectangle and also a rhombus.
Yes, sir, it's correct.
Good. A parallelogram is a trapezium.
Yes, sir.
A kite is not a parallelogram.
Yes,
It's
sir.
not
Not
parallel.
a parallelogram.
A kite is not a parallelogram. That is the correct statement.
Yes, sir.
A trapezium is not a parallelogram.
Yes, sir.
Correct?
Yes, sir.
Yes,
So
sir.
when you say yes, you should visualize what is trapezium and how it is. Okay? A rectangle or a rhombus is not a square.
Yes.
Got it? Exactly. So when you say all these statement, yes, sir, whatever you said is correct. that gives me also a confidence. Yes, we are moving in the right direction. We are able to make sense out of it. So I'm just going to just write down this point here. All of you are able to view it, dear students? Correct, na? You are able to view all this statement here?
Yes, sir.
Okay, great.
Yes, sir.
Very good. So a square is a rectangle and also a rhombus. A parallelogram is a trapezium. A kite is not a parallelogram. A trapezium is not a parallelogram. The reason is given in the bracket. And finally, a rectangle is, or a rhombus is not a square. So fine, dear students. So what we are going to discuss is that we are going to our next point is that we want to discuss more on parallelogram. So the properties of parallelogram will be discussion of our next topic. So just give me a minute or couple of minutes so that I can start a new session on the properties of parallelogram.